here it goes, example number 4. Once again, we would like to solve and graph the solution. And once again, what I mean by solve here is, in the end, make sure you write your solutions in interval notation. So, solve and graph the solution. And the inequality that we have here is a negative 4 times quantity x plus 2, and then all that is the left side. We want it to be greater than 3x plus 20. Okay, so to solve this inequality, once again, we need to do all the proper distributive law and rearranging of the terms, and then eventually cancel and divide to solve for the appropriate x values. So what I can see here is I need to distribute that negative 4 to each term on the left-hand side. So negative 4 times x, negative 4 times 2. Make sure you change the sign as you multiply, because here we multiply with a negative 4. So the left-hand side, after this distributive law, is going to become negative 4x minus 8. And then we want it to be greater than 3x plus 20. And here, once again, I would like to keep all my x term on the left-hand side and then keeping all my non-x term to the right-hand side. So here I need to subtract 3x from both sides, and then I need to add 8 to both sides. And so and then what happens here is on the left-hand side, I'm going to have negative 7x. The inequality is still greater than 28. And so now, finally, to solve the inequality for x, I'm going to need to divide both sides by 7. That's the basic idea. But then keep in mind, now we are, in this inequality, we are dividing both sides by a negative number. So the inequality here, originally it was a greater than, now it needs to be switched over to a less than. So whenever you're multiplying or dividing by a negative number, your inequality is reverse sign. So here 28 divided by negative 7 gives me negative 4. So now here's my logical solution. So logically, any x less than negative 4 is going to satisfy the left-hand side greater than the right-hand side. However, now, so to graph the solutions, once again, we've had about 3 examples so far, so you probably at this point starting to have a good grip out of that. Negative 4, once again, it doesn't matter when you put it on the line as long as it's just one point, it's just one number on the line. And then x is strictly less than. So we want to shade everything to the left-hand side of negative 4, and I am going to put parentheses on negative 4, because negative 4 is not part of the solutions. We just want those values for x strictly lower than 4. Okay? And then the final step is to re-express the solution here in terms of the interval notation. And once again, the line is telling it all. The shading is going anywhere under 4, under negative 4, lower than negative 4, to the left of negative 4, and keep extending infinitely to the left-hand side. So I can see that it's going to be negative infinity, comma negative 4, parentheses on the two sides. And that's how we solve another inequality, linear inequality, for example number 4. And in example number 5, once again, each time we're looking into a new example, you can see that the problem is growing a little more and a little more challenging. However, as long as you carry the proper properties, you carry out the steps with the proper properties of inequality, things should be all fine for you. So here's, once again, we all want to solve and graph the inequality. And what I have here is a 5 times 3 minus x less than or equals 3x minus 1. So now, in this inequality, once again, similar to what we had earlier in the sense that we need to do a distributive law on the left-hand side. So here I see distributive law, the 5, but here it's a good thing, it's a positive 5. So 5 times 3 is a 15. 5 times negative x is a minus 5x. Right? And then less than or equals to 3x minus 1. And so, with this final inequality right here, so far, to solve it, you need to subtract 15 from both sides. Like I've said, we always need to bring all the non-x term to the other side and arrange all the x term to the left-hand side. And minus 3x from both sides here, that's going to be bringing all my x term to the left-hand side. And so what I have here is going to be minus 8x less than or equals to minus 16. And now one final step to solve for the inequality. dividing both sides by negative 8. Okay, and that gets me x greater than or equals to. Once again, the reason being, when you're dividing both sides of an inequality by a negative number just like this, your inequality signs turn around. And here it's become negative 6 divided by negative 8, positive 2. So my logical solutions, x greater than or equals to 2, meaning for any values 2 or higher, the inequality, the left side of the inequality will be less than the right hand side, less than or equals to the right hand side of the inequality. So now graphing this inequality, once again, draw for yourself a line of number, and you can put in anywhere on the line a number 2. Just right there, I put it. The logical solution is saying I want x greater than or equals 2, so of course we are shading to the right hand side of 2. And then right at 2, do I want to include 2 as part of my solution? The answer is yes, because the logical solution, the x greater than, the final inequality here is indicating x greater than or equals 2. So I do want to accept 2 as part of my solution, and that's how I graph it. And then finally writing the solution here as in integral notations. I have 2 comma infinity. That's how I can write it in integral notation. Okay. Another example for you to get more and more comfortable with solving inequality. This time we're still doing the same task here. We would like to solve and graph the inequality, but then let's get some fractions involved here. How about 7 minus 4 over 5x? Okay, less than 3 over 5. Okay, so I have some fractions involved. But however, the good thing so far is we have like denominators throughout those fractions. And so what I need to do, here's always the trick. It doesn't matter if you're solving equation or you're solving inequalities. When you're encountering with fractions, always find for yourself the LCD, which is the least common denominator. So in my case here, throughout all the possible fractions, I have 7 here, you can think of that as 7 over 1. I have the fraction 4/5, I have a fraction 3/5. So my LCD in this case is a 5. Now, LCD is a new term I'm introducing here. It's not really new. It's new in these examples. However, it should not be new to you. So if you're not sure, if you're feeling shaky with your LCD skills, make sure you go back and review on your LCD skill as well. So here I'm telling you, the LCD for all these denominators here is a 5. So now once I found the LCD, what I need to do is I'm going to multiply the LCD throughout all the terms on the two sides. So once again, I'm going to multiply the LCD to all the terms throughout the two sides of the inequality. So here, first of all, I have 7 times 5. So I have 5 times 7. And then minus, here I have 5 times 4 over 5x. And then on the other side, less than 5 times 3/5. Now, did I change my inequality? I did not change my inequality because the number I multiplied, the 5 that I multiplied to both sides, that is a positive number. That was a positive number. So I did not have to worry about switching my inequality. So now, by the way, 5 times 7 is 35. Now, the whole purpose of multiplying the LCD to two sides here is we would like to cancel the denominators away. We need to clear fractions away. That's the point. So 5, cancel with that 5. That's gone. So we have just remain 5x. And once again, if you're not sure with your fraction cancellation skill, you also need to review on that skill. Less than, here my 5, cancel with the 5. Less than 3 on the right hand side. So now my inequality turns out to be much nicer than it was before. So to solve for x, I need to just simply subtract 35 from both sides, and that gives me negative 4x less than negative 32. And so the last step to solve for x, dividing both sides by negative 4, and that gives me x greater than positive 8. And once again, what just happened here? My inequality reversed in direction just because I divided both sides by a negative number. So, once again, x greater than 8 is my logical solutions to the inequality. Now, to graph the solutions, I draw for myself a line once again, and here's 8. Anywhere on the line, that can be my 8. Any point on the line. And then I'm shading, the inequality is indicating greater than 8. So greater than 8, I need to shade anywhere to the right-hand side of 8. And here, 8 is not part of my solution, so I'm going to have to exclude 8 and using parentheses right on 8. So that's how I graph my solution. And then the inequality here, the final expression here in terms of interval notations, you're going to go 8 comma positive infinity, parentheses on the two sides.